8.5 is an introduction to vectors. So have you guys heard of vectors before? Do you know what I mean by that? Yeah, so vectors are used a lot in physics. So if you guys go on to take a physics class or whatever, you're going to see vectors a lot. You also do a lot with vectors in pre-calculus. So we don't deal with vectors in Algebra 2. So this is just kind of an introduction to something that you might see like in your junior year or senior year. Okay, so it says vectors are an important concept used every day in the world. So a vector is a quantity that has both magnitude and direction. So magnitude is like a length, and direction is like the angle that it's pointing in. An example that we would constantly use would be like the speed of planes. So the speed would be the magnitude, and then the direction that they're flying. So there's something that we refer to as bearing. So think about as you're flying a plane. So imagine you're flying a plane, and I say 10 degrees off course. Would you guys know what 10 degrees off course would mean? That would mean that as you look forward, you're going to the right, like 10 degrees. Does that make sense? That would be bearing. Okay, but in this class, we're going to talk about something that's called the standard angle measure. So the point 2, 3, you guys know that when we talk about the point 2, 3, you know how to graph it. You go over 2 and you go up 3, right? So that's the point. Okay, so that would be using parentheses. That's 2, 3 with parentheses. But if I write something that's 2, 3 with these little pointy parentheses, okay, that's a vector. Okay, so there's a distinct difference. Do you guys see the rounded parentheses versus the pointy ones? And what that would represent is this line segment, like a ray, basically, that goes towards that point, 2, 3. Okay, so that has a certain length there, and it has a direction that it's pointing. I know a ray has an infinite length, but it stops at that 2, 3. Okay, so the magnitude is the length of the vector. And if you guys think about how to find that length of the vector, it should make sense. So all of you guys are in a geometry class. You should know how to sketch things out and how to get things. So think about if I drew this little triangle in. How would I get the length of this line if I know this is 2 and this is 3? Yeah, exactly, Pythagorean theorem. So I would do 2 squared plus 3 squared equals that distance squared, right? So I'm going to write d squared. And then I would take the square root. So I'd get d is equal to the square root of 2 squared plus 3 squared. That is what this formula right here is. It's just the square root of the x coordinate squared plus the y coordinate squared. Rowan, can you close that door? I don't know what they're doing in the hallway. All right, now the direction is going to be the angle. Thank you. So you guys just learned SOHCAHTOA. So imagine that I went over 2 and up 3. So I had 2 and I had 3 here. And I wanted to find this little angle right here that I'm drawing in blue. Okay, think about how you would set up an equation. You would say, so we have the opposite, we have the adjacent. What uses opposite and adjacent? Tangent. So we would say tangent of our angle, which I'm going to write as theta. I know you guys don't like seeing thetas. You don't like using Greek letters. You want me to use like A or something. But we're going to be, you know, sophomores, juniors. Someday we're going to have to use theta. So we have tangent of theta equals opposite over adjacent, 3 over 2. And then remember, if you want to solve for an angle, so if we want to find what this letter is right here, we would have to get rid of the tangent. And we do that by doing inverse tangent. So it would look like theta equals inverse tangent of 3 over 2. And that's what this formula is right here. So tangent of theta equals y over x, and then you would do inverse tangent to solve it. Does that make sense? Do you guys see how it's like 2 things that we know already, Pythagorean theorem and SOHCAHTOA? Okay, so the annoying thing is that people were working with vectors a long, long time ago, and multiple people were doing it at the same time. And this happens a lot in math. So a lot of times there's like French mathematicians or German mathematicians that come up with kind of the same concept. And then they publish these books and so on, and they have different notations. Okay, so it can be frustrating for mathematicians when you see different notations. So it says sometimes we use a bold letter to represent a vector. So notice how we have a bold U equals some vector U1, U2. And then sometimes we use a ray symbol above it. So sometimes it looks like U with a little, we call it a harpoon. You guys see that little thing up there? Other times we use the letters I and j to represent it. So if I say negative 2i plus 3j, that means the vector. Do you guys see this right here? Negative 2i plus 3j. It's really the vector negative 2 comma 3. Okay, so don't let all these notations confuse you. They all mean the same thing. So I always hated the ij notation. I was like, why can they not just write it with the pointy parentheses? Jeez. Very annoying. All right, so here we go. So it says sketch the following vectors and then give their directions and magnitudes, and then if needed, we're going to round to 3 decimal places. Okay, so let's draw this out. So if I have 5 comma negative 12, do we all know how to draw the point 5 comma negative 12? Yeah, so start there. So draw the point 5 comma negative 12. Should have used smaller tick marks here. I forgot I have negative 12 here. Okay, so it's in the 4th quadrant. And then what a vector is it starts from the origin and it points towards that 5, negative 12. So our vector is going to be this blue line that I'm drawing in. And it has an arrow on it, but it really like stops at that point. So this is the vector 5 comma negative 12. So this vector has a length to it. Do you guys remember from our Pythagorean triples the other day what that length is going to be? It is going to be 13. So we draw on this little triangle, and we're like, okay, this is 12, and this is 5, so this would be 13. Okay, so you could get that with the Pythagorean theorem, or you could get it with the formula. So the way we represent magnitude is we use a little line. It's like an absolute value. Okay, sometimes you might see it with 2 lines, but I'm lazy and I try to do the minimum and I just do 1. So it's okay, you can do 1 line. So it's the magnitude of u is going to be the square root of 5 squared plus the negative 12 squared. And you can check, but that ends up being 13 because that Pythagorean triple we learned yesterday or Wednesday. All right, now we need to find the angle. So we're going to do tangent of theta. So our angle is always here. So we want to find that angle. So we have opposite. Actually, I think I lied on where my angle was. I drew it in the wrong spot. Why did I say it was always there? I knew it wasn't always there. So here's my triangle that I'm going to talk about here. It's always opposite over adjacent. So opposite is here, adjacent is here, okay? So if you look at our formula, do you guys see how it was the y value over the x value? That's what we're doing, so y over x. So we're going to have the y value is negative 12 and the x value is 5. So get your calculators out and we're going to do inverse tangent of negative 12 over 5. So we do second tangent, so inverse tangent of negative 12 over 5. And in this case, we get a negative angle. All right, so I'm not going to go into too much detail on why that's a negative angle. Yeah, why is it a negative angle? You're going to talk a lot about this in pre-calc. Basically, it's like, when we talk about angles, they're always starting along the x-axis. Look up here, guys. So Jacob, turn around. So angles go around like this. They go around in the counterclockwise direction. So when we have a negative angle, what it means is it went this way. Okay, so what this angle is right here is it is 67.380. Okay, but when we want the standard angle, we want it to start on this axis and go all the way around to the blue line, to the vector line. So put on your thinking caps. It's going to be an angle. It's not going to be quite 360 degrees. It's going to be less than 360 degrees. It didn't go all the way around. How do I get that? 270 would be going here and then stopping right there. But ours goes a little bit past, right? It had that blue line. Yeah, what do you think? Yeah, we take our 360 and we subtract out that 67.380. So it's okay that we had a negative, because what we're going to do is we're going to adjust it by adding 360 to that negative number. Does that make sense? So we end up getting, so we're going to say plus 360. So we end up getting 292.620. Okay, and that's going to happen a lot with tangent. We're often going to have to add either 180 degrees or 360 degrees, depending on what quadrant it's in. So maybe write yourself a note. Like, we will add 180 or 360, depending on the quadrant. So that's why it's important to draw the sketch out. Okay, so let's try this next one. So we have 1 comma root 3. So if we have 1 comma root 3, we're going to go over 1, and then we're going to go up the square root of 3. So square root of 3, if you find it as like a decimal, it's around 1.7. So we're going to go up a little bit between 1 and 2, but a little bit higher. So like closer to the 2 than the 1. And then we draw it in by drawing in our line. So that's the vector 1 comma root 3. Okay, so you can sketch out the triangle and get it that way, or we can know what these formulas are. So remember, the magnitude is the length. We represent magnitude by doing like an absolute value. So the magnitude of u is the square root of the x value squared plus the y value squared. What do I get when I do square root of 3 squared? 3, right? So I'm going to add it to 1, right? 1 squared is 1. So I have square root of 4. What's square root of 4? 2. All right, so the magnitude of u is 2. And then we need to think about the angle. Now this is in the first quadrant. So what's our angle? What's it going to be between 0 and, if it's in the first quadrant? 90. Do you guys see that? If we're talking about starting here and going around. So we're between 0 and 90. So let's do our inverse tangent and see if we get something between 0 and 90. Well, hang on. Let me write tangent of theta equals. So tangent of theta equals the y value over the x value. So when we do inverse tangent of the square root of 3, we don't need to do divided by 1 because it's just square root of 3 still. This one came out nice for us. What did we get? 60. Yeah, we got 60 degrees. Okay, the reason is because that ends up being a 30, 60, 90 triangle. Crazy, right? Think about it. If you had a 1 here, you had 60 degrees. This is going to be double the hypotenuse, and then this is going to be the 1 square root of 3, right? So it's a 30, 60, 90 triangle. All right, so how about the next one? The next one I think you could probably do without doing any formulas. So we got to think about where it is. So we have 0, negative 4, 1, 2, 3, 4. So our vector is right there. So let's think about what these definitions are. Magnitude is the length. How long is that line? I shouldn't say how long is the line. How long is that vector? It's 4 units long, right? Does that make sense? 4 units long. So we're going to say the magnitude of u is equal to 4. Here's the tricky part. What's the angle? 270. You guys got it. Good. Perfect. So theta is equal to 270 degrees. Does that make sense? Do you guys understand that? So this is vectors. So you're not going to do much with vectors, like I said. Like, you're not going to do anything with it in Algebra 2, but you will see this someday. And in math classes, we like to kind of preview something in one class and then do it more in another class. So this is where we're previewing. All right, so this last little bit that we have, well, I think we have a little bit more here. So it says, find the direction for each. So sometimes we use really weird sayings. I always hated these in school. I don't know. So when you see something that says 25 degrees east of north, we need to know what that means, because sometimes they're in story problems. So if I say 25 degrees east of north, okay, what we're going to start with is the north. Okay, so we're drawing this like little north, south, east, east, west, like a and we're starting with the north line. And we're going to go 25 degrees east of that line. So think about where that would be. Do you guys know your west versus your east? It spells out we. That's what I always had to remember when I was in school. We. Okay. Not ew. We. All right. So how do we go 25 degrees east? Do I go to the right or the left? To the right. So I start with my north line and I go 25 degrees east of north. So what we want, when I talk about the direction, that's our standard angle. So starting with the x-axis and going counterclockwise. So what's the direction then? What do you guys think? You guys paying attention back there, Max? Sam, you got it? How many degrees are left if I have 25 degrees there? There's 65. That's the direction. Okay, easy enough? Okay, so 42 degrees west of south. So we start with our south line. We go 42 degrees west of that. So we go this way. So then what's our standard angle? How do I find it? Yeah, we could do 270 minus 42. So we get 28? So 228. Does that make sense? Do you guys get it? And there's lots of other ways you could have found this. So maybe like some people like to find the rest of the acute angle. So they're like, oh, that's going to be 48 degrees. And then they do 180 plus 48. So you could have also done that. So you could have found that this was 48 and then done 180 plus the 48. So either way. Make sense? All right, so it says vectors don't always have to have their tails at point 0, 0. So you don't always have to start at that origin. Okay, so this is where it gets a little bit weird because we can move vectors around. So vectors could be all over the coordinate plane, and we can move them wherever we need them. So this will make more sense to you in a little bit. So suppose we have the vector 3, 4. Let's sketch it starting at 0, 0. So if I have 3, 4, it's like this. But I could have lots of vectors with that direction and magnitude, okay? But they could just be moved around. So let's think about other places that would have 3, 4. Well, I could go down 1, 2, 3. Maybe I'll go down 4. And it could point like this. Doesn't that have the same, it's like parallel, right? So it kind of has that same angle and same length. But I could move things around. You don't have to be like perfect with these. I could have something like that, right? As long as it's going in the same direction, so it's parallel and the same length, okay? There could be an infinite number of those. So the head minus tail rule says if an arrow has an initial point of x1, y1, and it has a terminal point of x2, y2, it represents the vector x2 minus x1, comma, y2 minus y1. Okay, so the terminal is the head, and the initial is the tail. Do you guys know what I mean by that? So this is the head, and this is the tail. So that's why we do the head minus the tail. So terminal minus initial. Okay, so it says find the vector a comma b with points -2, 0 and -6, -7. Clearly mine's drawn to scale. Oh, whoops, I drew mine the wrong way. It should be pointing, so it started at -2, 0 and it points to the -6, -7. And the reason I know that is because you guys see how it says A, B, and the arrow's on B? So I should have the arrow pointing towards the B point. So this was A and this was B. Okay, so imagine we took this vector and we just moved it over. It would be here. Right, it would just be moved over. Well, let's try this trick, this head minus tail thing. So if I have the point -2, 0 and -6, -7, I'm going to take the second one and subtract out the first one. So I'm going to have negative 6 minus a negative 2, comma, and then I'm going to have negative 7 minus 0. So I get negative 4, comma, negative 7. If you plot negative 4, comma, negative 7, it's right there. Oops, I should have extended my line a little bit. It's the same vector, it's been scooched over 2 units. Do you guys see that? So we just move it so that it starts at 0, 0. Okay? So try the next one. So it says find the vector C, comma, B. So you don't have to draw it out if you don't want to. So if you were doing CB, think about how you would do that. So go ahead and try to find it. Did you guys get 8, negative 14? Good. Okay, so you could sketch that out and you would see it's the same vector, it's just been moved, so it starts at 0, 0. Does that make sense? You guys get it? It's kind of weird when you first learn vectors. And really, like, I wrote CB kind of like array with that line up there, that arrow up there, which we do sometimes for vectors. But a lot of times in books, you're going to see it with the harpoon thing, which is just part of the arrow. Do you guys see what I'm talking about? Like, it's just going to look like that. So you can draw it either way. All right, so find the component form for each vector. So really what we're doing for each one is we're finding the initial point and the final point. So this one was 1, 0, and its final was, what is that? It's hard to see for me. 5, 8. Is that what it is? So U is going to be 5 minus 1, 8 minus 0. So it's the same as 4, 8. Whoops, that should be a minus in there. Okay, so you can find each of those component forms. Does that make sense? So go ahead and try a couple more. So find like V and W. Oops, I wrote U again. So V and W. If you get to it, you can find Y as well. It depends on the final point, like where the arrow is. That's what you're starting with when you're subtracting. So negative 9, 8. So V is just negative 9, 8 still, because its initial point was 0, 0. Okay, so W, you should take the negative 7, negative 1 first, right? Because that's where the arrow was. So you're going to have negative 7 minus a negative 9, and then negative 1 minus 8. So what do we get here? 2, negative 9. Did you guys get that? Yeah, is this making sense? Do you guys get it? And then I don't know where Y is. Let me look. So negative 5, negative 2. Let's see, so we get 1 minus a negative 5, and then negative 7 minus a negative 2. So you're always doing like the tail part, like the head minus the tail, I guess. So what's this one? 6, negative 5? Yeah. It's making me think. You gotta just blurt it out for me. All right, makes sense? Okay, and the last thing we're going to talk about is like adding and multiplying. So it says adding and subtracting two vectors is exactly what you would think it is. It's actually really easy. So the sum of two vectors is you just add their components. So if you had U was U1, U2, and V was V1, V2, when you add the two vectors, it's going to be U1 plus V1, comma, U2 plus V2. So you just add the x values together, you add the y values together. And then multiplying, if you have k times the vector U1, comma, U2, that's a 1 there. You just multiply the k into both of them. So it's going to be k U1, comma, k U2. Okay, so it says there are two different geometric representations of vector addition. So one is called the tail-to-tip representation, and then, so in this representation we move the second vector to the end of the first vector, and we draw a line. And then the other one is the parallelogram representation. So on the right side is the tail-to-tip. So if I had B and I wanted to add A to it, I take A from wherever it was located, and I move it to the end of the first vector. And then I can find their sum. And then the same thing here, we have a parallelogram. And so if I have A and B, I just create the other sides of the parallelogram, and then it's the diagonal of the parallelogram. Okay, so the reason we would use like vector addition, so what my pre-calc class is doing right now, my summer pre-calc class, is they are talking about like airplanes and wind. So imagine I have an airplane that was supposed to travel in this direction. So it has a certain speed, so that's the magnitude, and it has a certain direction. But there's a pretty strong wind that's pushing in this direction. Maybe I'll make it a little bit smaller, it's not going that fast. Okay, so it has a certain magnitude, so speed, but it's not as much as that airplane. The airplane's going much faster, right? So I made it longer, and it has a certain direction. What will happen to the plane? Guys, look at the picture. What do you think is going to happen to the plane? So these are all like forces. Like imagine I'm pushing with a certain strength in this direction, and then something else is pushing in this direction. What happens to this plane? It kind of like curves in a way. Not curves, it's still straight, but it's going to go a little bit off course, right? That's what vector addition is. It's taking the wind and moving it to the end, still in the same orientation, and that's the new planes. So it changes the plane's speed. It makes it like faster or slower, right? If the wind was pushing behind, would it make it faster or slower? So if I have my airplane and the wind was behind perfectly, what makes it? It makes it go faster, right? We know that. You guys have all been on a bike before and you've been going into the wind or going with the wind, right? So this is what vectors do. So it's actually very important in real life that we know vectors so we can know how fast that planes are going to get there. All right, so it says u equals 5, negative 2, and v equals negative 3, 4. So find the component form of the following vectors. Sketch rough graphs to show what is happening here. Okay, so let's draw a rough graph. So if I have 5, negative 2, and try to draw it as precise as possible. I know it's hard sometimes. So that's vector u. And then vector v is negative 3, 4. Oops. If we're finding u plus v, we're going to take, it doesn't matter which one because v plus u is the same thing, but let's say we take v and we move it. So I'm going to move it to the end of u. Okay, so from u, I'm going to go over 3 to the left and up 4. So I'm going to go over 1, 2, 3, up 1, 2, 3, 4. It's going to go right there. What this creates is like a little parallelogram shape. Sorry, my first line wasn't very straight, so that's causing me issues here. Do you guys see how it's kind of creating this parallelogram shape? The resultant, so u plus v, is this line right there. It's like the diagonal of that parallelogram. Okay, so this is the u plus v. Okay, it's a little weird, I know. Okay, let's see if it worked out to be what we thought it was going to be. So u plus v is going to be 5 plus negative 3, comma, negative 2 plus 4. Does it look like 2 comma 2? So look at our, so it started at 0, 0. Does it look like over 2, up 2? Yeah, it looks like 2 comma 2. Okay, so you can do this without drawing the sketch in, but we're just showing you what's happening with these vectors. So what do we think 4u is? Yeah, totally, 20 comma negative 8. This would be a hard one to sketch, but I'll try. So I need it really big in the right side, so maybe I should draw it a little bit to the, we'll draw it like that. So u was 5 comma negative 2, it was this. How do you think it affects it when we do 20 comma negative 8? Well, let's see. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, still almost didn't have enough room. 3, 4, 5, 6, 7, 8. I'm having trouble drawing straight lines. So what do we think happened? It's now 4 times bigger. So we had that one. Let me do it here. 1, 2, 3, 4. Right, we have 4 of them now. Makes sense? So the magnitude is 4 times longer. What about the direction? The angle? Still the same, right? All right, does this make sense? Do you guys get this? All right, so 2u minus 3v. So let's start with the 2u. So 2u is going to be 10 comma negative 4. Right, we just take our u and we multiply it by 2. And then our negative 3v was 9 comma negative 12. And basically we just add these two vectors together. So I get 19, negative 16. So I won't make you draw it, we'll just say it's 19, negative 16. It's exactly what you would think it is. It's like you distribute the 2, you distribute the negative 3, and add them together. And then negative v, we will talk about what this one looks like. So if I have negative v, let's draw v first. So v is negative 3, 1, 2, 3, 1, 2, 3, 4, negative 3, comma 4. So that's v. What do you guys think negative v is? Yeah, Roman? Yeah, it's 3 comma negative 4, right? And 3 comma negative 4, 1, 2, 3, 1, 2, 3, 4, is the same vector, it just goes in the opposite direction. That would be negative v. Does that make sense? All right, so that's vectors. Do we feel okay with it? It's kind of weird, but at least you've seen it one time, so